In this video, I guide you through the versatile slanted roof feature. Let's get started! This process starts with accessing your existing project or create a new one with the Shaft Wizard. The next important step is to activate the roof feature. To do this, go to the main project data interface. Under the Shaft options, locate the Roof section and select it. A simple click on the Roof tab will immediately activate the important component. An alternative method for activating the roof involves utilizing the data tree, where you can locate the roof subordinated to the shaft. Confirm its activation by observing the breadcrumb window, which indicates its status when selected in the data tree. Let's explore the process of creating different typical slanted roof designs. To enter consistency in preparation, set the top wall thickness WO to 0 for independent wall configuration. Access the Group and Shaft configurator, proceed to Material configuration, and select Brick for all walls. For the face right wall, switch to the Roof Face Right mode and set the angle to 40 degrees with a 200 mm offset. Combining both left and right walls is straightforward. Activate Roof Face Left and Right and input values like an angle of 45 degrees and a 300 mm offset. For the untypical slanted roof, switch the Roof Face Left and Right mode to On. Now, let's input specific values to create the untypical slanted roof. For the Roof Face Left, set the angle to 45 degrees, the thickness to 150 mm and an offset of 400 mm. Mirror these exact values for the Roof Face Right. Moving on to the Roof Face Top, the angle is automatically set to 0 for the roof surface at the top. Input a thickness of 250 mm and an offset of 1200 mm to define the top surface. Next, go to the Options group and make sure to select Yes for the Keep the Original Ceiling option. This ensures that your existing ceiling design remains unchanged. To uniformly adjust the wall thickness, set Thickness manually to No for each roof face. Now, under Options, input a thickness of 180 mm. Let's talk materials. You have the flexibility to choose an alternative material for the roof. For this tutorial, let's stick with wood. Additionally, for the wall extension, opt for concrete. Let's explore another interesting feature: negative directions on slanted roof faces. Head back to the options and set Keep the Original Ceiling to Yes as top roof face. Choose concrete beam as an alternative material and set None for the wall extension material. Now you can add a minus sign in front of the values and turn off the Roof Face Top. This feature is useful when you want the shaft height to align with the roof, not surpassing it. Initiate the process by accessing the Additional Objects window, located under the Start tab. Activate the shaft and click Add New under the Additional Child Objects. The navigator will open, enabling the selection of a model from the DigiPara BIM library. Determine the profile type via the navigator window. We need an upright I-type profile. Confirm your selection with OK. Assign the shaft component group to control the visibility of the new user component and click Finish. After adding the profile, rename it as Upper Beam by clicking at the pen icon next to the object. Specify the correct dimensions by entering values in the properties. Ensure the upper beam is active and go to I-type. For DXL, we need the sum of the shaft width and the shaft left wall width. In our example, it's 2215 mm. For DXR, it needs the shaft right wall width, which is 200 mm. The value for DY, the shaft depth, is 200 mm too. And for DZ, the shaft height, 100 mm. Now let's locate the upper beam. Go to Location in the Properties and set the Position and Angle calculation to Manually by Equations. The position of the X direction is the value of the shaft width, dx. In Y direction, it needs the half of the shaft depth so that it is in the middle. At last, the value for Z0 is the shaft height, dz. This concludes our tutorial on effectively handling the new slanted roof feature. Thanks for watching!